Okay, so in this session we'll be talking about understanding the way permissions are to be interpreted in case of Unix. So each file that we talk about would have certain permissions associated with it. So Unix identifies three different type of people or groups to whom the permission could be assigned. I will name them as parties going forward. So the Unix identified three parties are owner, who created that file, the group members, so these are those people, those who are from the same group as that of the owner of the file, and then all others who do not fall in the category of owner, neither fall in the category of members belonging to the same group as that of the owner, that is group members. All such people would be called as others. Now owner of the file is shown as third column in your ls-l commands output. The group of the file or the group ownership of the file is shown as the fourth column in your ls-l output. Now when we talk about, so that was all about parties, and then we need to understand what are the permissions associated with a file or a directory. So for each party, that is owner, group members and others, there are three separate permissions for each one of them. Read, indicated as small r, which has a numeric value as 4. So if I say r, it's a text notation. When I say numeric value 4, it's a octal notation. You are free to use any of these notations while typing the command. So either say read is r or is equal to the octal value 4. Write is w with the octal value as 2, and execute is indicated in text format as x with the octal value as 1. And when I sum up them, 4 plus 2 plus 1, it comes to 7. So the highest permission that can be ever assigned on a file or a directory, either to the owner or to the group members or to others, could be any combination of it, but will not certainly exceed 7. So there could be only read, write or execute, or all of them read, write, execute, which means 4 plus 2 plus 1, which is 7. Each party can thus have any combination of RWX commands. So owner can have his own set of RWX on permissions on a given file or a directory. Group would have its own set of RWX, and others would have its own set of RWX permissions set on a file or a directory. Now when we look at the ls-l commands output, then the first column is of 10 characters, we said, where the first character in the first column indicates the file type, whereas remaining 9 characters from the first column are nothing but file permissions. So I am logging in here as Dick and I am looking at the ls-l commands output. So the first character in the first column indicates the file type that I am dealing with, and then there are a triplicate permission set RWX, RWX, RWX. The first RWX is for the owner, the second set is for the group members, and the third set is for others. So when I look at who is the owner, in my case it's any user named Dick. I said to which user group he belongs to. He is a member of a group. The name of that group itself is Dick. Now whenever normally this happens that the username and the group name is same, such a group is called as a private user group. Typically this is created when you create a user without mentioning the group. then in that case group with the same name as that of the user would be created. But when I move on to some other user, let's say user 30, and then I look at these files, you will realize that the user is user 30, but he belongs to a group called as Unix Lab. And there are then many other users who are also part of the same group called as Unix Lab. For all such users, say for example, user 30 would have read, write, execute on this file. Other people, those who are part of Unix Lab group, would have read and execute permission on this file or directory. Then others, who is neither user 30 or nor a member of Unix Lab group, would have permissions as read and execute but no write. So there are three parties, and each party would have on a given file or directory three different permission sets: read, write and execute for the owner, read, write and execute for the group member, and read, write, execute for the others. Not every regular file in Unix is an executable file is an assertion. We start with a base assumption that whenever I talk about a regular file is indicated with a hyphen in the first character position of the first column in ls-l command. So whenever we talk about a regular file, by default Unix assumes that a file would not be executable in nature. Quite understandably true. If I create a file, that doesn't mean it contains executable instructions, right? So here I am. I am going back to my original login, that of Dick. And you see here, is this a executable file? It's of 0 bytes. Is this a executable file? No. So Unix starts with a base assumption when we talk about regular files, that whenever there is a file, it will not be executable in nature. Now, for most of the times this assumption works fine. But what if I really create a executable file? Then since it's a regular file, Unix base assumption would apply, saying this is not an executable file. But I want to mention it otherwise to Unix. Then on such files you set up the executable permission. So don't expect that there is a file file2.txt, it contains no executable command instructions. It purely contains text. So that's why when I check the execute bit permission for the owner, it's missing execute. When I check the execute bit permission for others, it's missing execute. When I check, group members, and when I check it for others, it is again missing execute. That is because it goes hand in hand with the Unix's base assumption. The base assumption says that a regular file in general is not an executable file. But consider a case that I am creating really an executable file this time. I will call this as program 1 dot extension really doesn't matter. So I called it as txt, and then I am saying echo, hi there, echo today is. So I am typing some executable instructions here. This is not a text. This is executable instruction that I am typing. Now when I check the permissions for program1.txt, it feels like it's just a regular text file. But I know for sure this is not a regular text file. I am the one who have added the executable instructions in this file. So see, if I try to examine the contents of that program1.txt using a command called as file, see what it reportedly shows me. See what it says? It says it contains ASCII text. That is the base assumption. That's why if it contains ASCII text, then it cannot be an executable file, right? The base assumption says that all files are textual in nature by default, and that's why they cannot be executable. But I know better than Unix in this particular case that this is not my text file. It contains executable instructions. This is the time, let's not worry about the command. This is the time when I mark that particular file as executable. Don't worry about the command part. So now see, Earlier there was a missing execute for the owner, for the group member, for others. Now for all of them I have marked the file as executable. Immediately the color convention also changed. Now if I try to examine this file, it still reportedly shows as a ASCII text, but the color change, only this is applicable in Linux with ncurses libraries, that the colors would be different. Otherwise in all other Unix it's black and white environment only. But I can make a visible difference, at least in case of Unix here, Linux here, that my visible appearance of the file, the way it was listed earlier and now, has changed. If I run it as a program now, see here it gives me an output. I ran it as a command, I ran it as a program. So people say, what would happen if I change file2.txt as an executable file? So I said, what are the current permission? Missing execute for all. Then I said, this is file2 marked as executable. I am checking. It's all executable. Color appearance has also changed and execute bit is populated for all the three parties. Now when I run it, do you expect it to run? Certainly not. It says it does not seems to have executable instructions. So understand the base assumption of Unix first. Not every regular file in Unix is an executable file. Unix by default treats every regular file as a general text or ASCII text file. If however the regular file contains executable instructions, you must mark the file as executable. Otherwise the file is, regular files are never marked as executable. If you don't, then you won't be able to run it like a program. If I don't make it as an executable, I won't be able to run it as a program. See, what if I remove from my program.txt the executable instruction or executable bit? See here, instructions are still the same. I never change the text, commands are still the same, but I mark the file as non-executable now. And now when I try to run it, it says you do not have a permission to run it as a program. So understand what is the significance of execute bit in case of Unix or Linux operating system. So by default, regular files are never treated as executable. But you are a better judge than Unix. That's a base assumption. If you have really added executable instruction or commands to a file, if the missing permission, execute permission is missing on that file, and you try to run it, it will say you do not have permissions to run it as a program. So mark it as executable first, because you know better than Unix that this is now containing executable instruction, and then run it as a program. Now how I ran it, what instructions I put, that's not the point to be discussed now. Throughout our discussion, some point in time it will be clear what command I use, what instructions I typed, why I converted it. But the base assumption as of now which is relevant for this discussion is, not every file in Unix, regular file in Unix, is an executable file, and that's why Unix by default treats a regular file as a general text or an ASCII text file. If however the regular file contains executable instructions, you must mark it as executable by changing the permissions, and if you don't do this, you won't be able to run it as if it's a program. Just marking a general text file and as an executable would not make it run as a program. So some people said, what if I type my resume in a text file and mark it as executable, will it be automatically sent to an HR agency? So certainly not. So general text cannot be run as a executable one. The file must have executable instructions, and on top of it you must mark it as an executable. Now with respect to file and directory, there is a different meaning and interpretation of read, write and execute. Let's not worry as of now about a directory. So what I am going to do, I am going to hide the directory part. Let's first focus on understanding what does read means for a file. When permission for a given party allows him to read a file, that means the party can then copy or see the contents of the file. Now understand what I am meaning. Each and every word here is very important. We are all beginners to Unix. Now, if I say who am I? Who am I? I am user 30. User 30 is which party? Owner. User 30 for this particular file, let's say test, is which party? Owner. But if I would have been user 1, who is user 1 with respect to this file? Is he a owner? No. Then who is user 1 in this case? Group member, because for user 30 the group is Unix lab, and for user 1 also the group is Unix lab. So user 30 with respect to this file is the owner, but user 1 with respect to this file is a group member. If I say show me the ID of Dick user, now with respect to test, who is Dick? Dick is others. Now irrespective of whether I am talking about a owner or a group member or other, if they have read permission in their respective permission set, what they can do? They can copy the file, or they can see the contents of the file by typing the cat command. So cat shows the contents of a file. So this is what is the purpose of read there. Let's do a small demo. I am saying touch, or let me create a single line file. I am creating it under temp or somewhere else probably instead of temp. Let me create under U002. There must be some public directory here. I am creating a file called as vi oneline.txt. So who is the owner? User 30. What is the group ownership of this file? Unix lab. And what is the name of the file? One line. Now I am opening another session, and here I am logging in as Dick before I try out the demo. So I am now Dick. I am going to U02 TMP, and then I said oneline.txt. Now to which category Dick fits into? I am not a owner because the file ownership is user 30. I am not a member of the group because my group is Dick, not Unix lab. So the fitment for me as of now is that of a other. So with respect to this file, Dick user is neither the owner nor the member of Unix lab group. But does he has a read permission here? Yes. So in that case, can I see the contents as a Dick user? Yes. Can I copy this file as something else? Yes. Can I see all of them now? So see what read allows you. Read allows you to copy the file or see the contents of the file. Next one is understanding what is meant by write with respect to a given file. Let's not worry about directories as of now. Now, write allows you to modify the contents of the file, or it also allows you to delete the file. Now, when I am looking at does Dick have write permission on this file? Certainly not. So would I be able to edit the contents of this file? No. So see here, I am trying to edit the contents of the file. I try to save it, see what it says. The file is read only for you. Try exclamation. I said WQ exclamation. Let's not worry. It still allowed me to forcibly write to that file. Now question is, when I never had a write permission on the file and try to save a file in general regularly, it says no, you don't have a you don't have a write permission on the file. But when I forcibly write into it by saying exclamation, it allowed me to write. Isn't it a security violation? I do not have a write permission, but it still forcibly, when I said, it allowed me to write. Understand why it allowed me to write. In this case, the permission of the parent directory mattered more than the permission of the file. The parent directory is this one. I check what are the permissions on this directory. See, what does the directory allows me to do? So I am Dick. Whosoever is the owner, I don't care, root. But what it allows me to do on the directory? Read, write, execute. Because I am neither the owner, root. I am not the group member, root. I am Dick. And on the top level directory, it allows me to write to this directory, which means directory level permissions for write will supersede the file level permission. If I write to a directory, you will understand once we discuss about writing into directory allows you what, and then you will understand what it means by missing write permission on a file and why it allowed you to still forcibly write into that file. But in general, what could one do when somebody has a write permission on the file? If the permission is right, it will allow you to modify the contents. If the permission is right, you can also delete the contents. Execute is obviously applicable only for executable regular files. It allows you to run that particular file as if it's a program or command text. So let's understand this. So see here, I am saying vi user30 program.sh. So user30 has created a program. Echo, the owner of this is user30 is what I am saying. Echo, my ID is the ID command. And I am saving this file. By default, all files are marked as regular files are marked as non-executable. See here, missing executable. Owner tries to run it. See what it says. You cannot execute because it's not a executable file. Execute permissions are not marked on it. But I know this is not a text file. It contains a executable code. So I said chmod 7. Let's not worry about the numbers that I am playing with. 64 on this file. Let's understand what are the permissions now. What owner can do? Read, write and execute. What group members can do? Only read and write. What others could do? Only read. So I am here. Now I am Dick. Who is Dick with respect to this file? Other. Now see what happens if owner runs it. It says the owner of this file is user30. My ID is user30. See what happens if Dick tries to run it. It says you do not have execute permission because execute permissions are only given for the owner. Clear? So using this you can control read, write, execute permission either for the owner or for the group members or for others, and accordingly the behavioral aspect of your commands would change. So it does not allows me to run. Then Dick requested, would you allow me to run your program? So he said, that's fine, I can allow you to run my program. Now I am checking what are the permissions there. Everyone can execute. Dick, who earlier got permission denied, now runs it successfully. So understand the meaning. So coming back to my table again, while I want to still keep on hiding with respect to directory what it means. Read allows you to copy or see the contents of a file. Write permission, you may be whosoever. You may be a owner, you may be a group member, or you may be others. If you have write permission on a given file, it allows you to modify the contents of a file, and it also allows you to delete that file. Execute allows you to run that particular file as if it's a executable program code. So that's okay about file, except for the fact that there is still a debate about write permission. That even when there was no write, why it allowed me to write into that file. It shows me a warning, but it still allowed me to write. Coming back to that example one more time, those who didn't pick it up in the first attempt. On online.txt, others only have read permission. So can I modify this file? Dick, who is other. See, when I try to save this file, it allows me to save. Although at the first attempt it has shown me that you can't write to it. It shows me as a warning. Now it is not even me showing me the warning. Remember why it happened. It happened because the parent directory was having write permission for others. Now let's revisit what are the meaning of read, write and execute with respect to a directory. If you have a read permission on the directory, see what it allows you. It allows you to see the contents of the directory, but it does not allow you to see attributes. See what I mean by this. I am creating a directory here. I will create one level up. Here I am user 30. In the folder U002, I don't know if it allows me to write here, not here. So it's not allowing me to write because the U002 directory itself is owned by root. So we'll try to create it elsewhere. I'm going to U002 and TMP. Let me try to create a directory here. So I'm creating a directory called as user30dir. And then I would check the permissions on this one. See what by default it allows me. Read, write, execute for the owner. Read, write, execute for the group members. And read and execute only for others. Read and execute only for others. Now user 30 creates the same file here. See what permissions I have? This one. Now if I check, this was your original file. Now see what happens if Dick tries to modify it. I am into that directory. I have read permissions. Can I read the text of that file? Yes. Now if I try to modify it, see what happens. If I try to save it, it says the first time edition will show you warning saying read only file. You will have to add exclamation mark to override it. Now if I say WQ exclamation, see what it says now. Can't open file for writing. Now this time it never allowed me to write. Why? Because the parent directory does not allow others write permission on that directory, which is actually transcended to the file. So here the parent directory was allowing others to write. Here it's not allowing others to write. Understand the difference. So there was a write permission here for others. There is no write permission for others in this case. So if the file is not writable, then I certainly cannot write to that file, because my directory also is having a restrictive permissions not to write. Okay, now Dick is my friend. I want him to be able to write to this file. So I said 666. 6 means 4 for read, 2 for write, 4 plus 2 6. 6 for the owner, 6 for the group members, 6 for others. Now I am checking, can Dick write to this file now? Yes. Here I have never closed this. I said WQ. It allowed me to write to this file. See here. So understand the difference of write when the directory is having more liberal permissions. Understand the meaning of write on a file when the directory does not have more liberal permissions given on top of it. So that was all about file. Coming back to directory, if someone has a read permission on the directory, he can see the contents of the directory, but he cannot see any other attribute only in the presence of read permission. See here. I am user 30. I am in this directory. I can see everything. What are the permissions on this directory? The permissions on this directory are this many. Clear? Does Dick has read permission on it? Yes. Does he has execute permission on it? Yes. See what happens when Dick says ls to see the contents. Right? You can see the contents of a directory because Dick has read permission on the directory. But if read is the only permission on that directory, do I have only read or read and execute? I have read and execute. So I was able to list the contents and attributes of the files within that directory because of execute permission. But if the directory has only read permission, I can see the contents, but I cannot see the attributes. See here one more time. Now, user 30 is making this directory only readable by others. Only readable. This time it is readable as well as executable. See here what I am saying. I said 7, 6, 4 on the directory. So 7 means read, write, execute for the owner. 6 means, actually I should have said 5 and 4. So for others it is only read. For group members it is read and execute. And for owner all permissions. Next I check the permissions to confirm. Looking good now. So what permissions Dick has on this directory now? Only read, no longer execute. See what happens if Dick applies the same command now. You got the difference? I can read the contents of the directory, but I cannot read the attributes of the files within that directory. So understand this. You will be able to see the contents of a directory, but not any other attributes if you do not have anything other than read. If read is the only permission. So what does execute allows me then? Execute allows me to see the file attributes of anything that lies beneath a given directory. It also allows you to go into that directory and you can also see the file attributes. See, I do not have execute permission on that directory. I try to jump into it. I said take me there. See what it says? You don't have permissions. Why? Why I can't go in a directory? That means I do not have execute permission on that directory. So that prevents me, that prohibits me from jumping into that directory. I will change it back to what it was. So it was 755 on this directory. I am checking it one more time. So now Dick has read, so he can see the contents. Since he has execute, he can also jump into that directory, and he can also obtain other file attributes of files belonging to that directory. One more time, if I say this, I can see other file attributes, right? And I say cd, now I can successfully go to that directory as well. Clear? Very important. So don't say that executable for a file means it allows you to run a file as if it's a program, and execute on a directory means all the files within the directory are executable. That's not correct interpretation. Executable attribute on a directory allows you to go into that directory, or from outside you would be able to list out other file attributes within that directory. Read only allows you to see the contents. Now what is meant by write then? When you have a write permission on a directory, it allows you to create a file inside. It allows you to delete a file from that directory, and it also allows you to delete the entire directory. So do not grant write permission to people, those whom you don't trust. Because allowing a write on that directory means he can do anything with anybody. So that was the exact problem we had on TMP. What are the permissions? Very liberal, global permissions. Anybody can do, come and do anything to this file. Now I am going to U002 TMP, and I am checking for the files. Do I have a write permission on it? As Dick, I only have read permission. But what does my directory allows me to do? Write. With a write on a directory, what I can do? I can create a file of my own here. Let's try this. I say touch dick.txt. I was able to create a file. I can delete a file from it. I am deleting my own file. That's fine. It's my own file. What is not correct is, if I say this, it also deletes somebody else's file. This file was not owned by me. This was owned by user 30. But my directory says you have write permission, and write allows me to create any file, delete any file, and also delete the directory. Well, I am not going to do that because this is required for our practicals. So I am not going to delete it. So it also allows me to delete the entire directory, which is very dangerous. So do not allow liberal permissions on your files and directories until you understand what is the meaning of it. Clear? So very dangerous. Now what could be the solution for this one? People say that's fine. Now I want people should be able to, it's a project directory. Understand this? I said it's project. Members are user 1, user 30 and Dick. Good thing is user 1 and user 30 are part of Unix lab. Now I want to create a projects directory where these are my team members. User 1 and user 30 are part from the same team, Unix lab, and Dick user is from some other team, but we are all part of the project. All of us want to contribute our material under projects directory. Now see the risk. Since I want the project directory should be writable, what permissions I would be giving to me, myself, other, let's say I am the owner, user 30. What permissions I should give to myself? RWX for user 30 who is the owner, because I want to create files into it. What permissions I should give to team members, which is user 1. He is also a contributing member. So I said RWX to user 1. To which category user 1 belongs to? And there's also another team member called as Dick. He is also contributing member of my project. What permissions I should allow him on the projects folder? RWX for Dick, who is other. Now accidentally tell me, will it happen that Dick can overwrite a program written by user 1? Because finally directory allows me to do anything. Can I, Dick, delete user 1's program? Because directory allows me to write. Well, I am not doing this deliberately. Or I may be doing it deliberately. We have a common girlfriend. So you have any problem? So I want to give a hard time to user 1. Clear? So I as a Dick user, can't I delete somebody else's file? Can't I modify somebody else's program writing malicious instructions to it? ओनर उसका यूजर 30 दिखेगा, कोड मेरा लिखा हुआ है, उसमें मैंने वायरस लिखा डिलीट ऑल फाइल्स. रिस्पॉन्सिबिलिटी आएगी किसी ने रन किया ये प्रोग्राम तो किसके ऊपर आएगी? यूजर 30, because he is the owner of the file. He is supposed to be the one who has written a code on to this one, right? So this is the danger with globally writable locations. Never allow any Unix folder to be globally writable. Clear? So people say, what is the solution? This is my requirement. Solution is change permission something similar to this one. Is it the same or different? You need to pick it up. It's same or different? RWX, RWX, RW, this time it's not X, it's T. T is for public directories. This is called as setting a sticky bit on a directory. That T in the last position, if you see instead of X, that is to, so instead of RWX, RWX, RWX is dangerous. Instead I suggest you should create, instead I suggest you should create RWX, RWX, RWT. It indicates that the directory is public in nature but has sticky bit set on it. Okay, understand what is the meaning of a sticky bit. Now I will try to simulate the same whole thing, but this time with a sticky bit. See here now. I wanted to create that projects directory. See how I am creating this time. I am going to use 002. I want to create a projects folder here. So I said mkdir-p projects. What are the permissions? Something else. I don't want it this way. If I make it 777, it's very dangerous, I told you. So I am making it this time as 1777. Let's not worry what I am giving. It's not, मैं वो type क्या कर रहा हूँ ये important नहीं. Concept is important. chmod command anyways will come in future. See what you see now. मैंने दिया 777 ही, लेकिन उसके पहले क्या दिया मैंने? 1. 1 marks that particular directory with a sticky bit. Now instead of RWX, 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 which is 777, that additional 1 at the beginning has brought in a new character there in the others executable bit permission, that is T. Now I go to projects. There's nothing there. This is who I am, right? I create a file, touch user 30 dot program, whatever. See what are the permissions now, right? Now here I am as Dick. Dick also goes there into the same folder. Dick has read permission on it. So Dick can always read the file. Dick does not have write permission on it, so Dick cannot write to that file. Dick does not have execute permission on that file, so he cannot run it as a program. Can Dick create a file? Dick can create the file. Can Dick delete his program? Dick can delete his program. Can Dick delete somebody else's program? This is important now. See what it says? Operation not permitted. Although I have a write permission on the directory, you have known this earlier, right? But it still does not allows me to delete now. What the sticky bit does then? Sticky bit is set on public directories. So all people can, depending upon the permission obviously on the directory, can create files into it, but only owners can delete their own files. If I set it 777, anybody can do anything to anybody's files. But with the sticky bit, now it protects you from, or it protects the contents of that directory to be deleted by anyone else who has a write permission on that directory. Now only owner can delete it. By default, there is only one directory with the name /tmp which has a sticky bit set on it. The tmp directory has a sticky bit set on it. So tmp location can be used by everyone to create their temporary files. But who can delete those temporary files? Only owner of the file can delete the temporary or the contents of that directory. Well, the only exception to this rule is super user, root. Root can do anything. So you can't sticky bit or whatever permissions can't restrict root. Root is always irrespective of all the permissions. Permissions of a file and directory can be changed using chmod command. Now actual technique of changing it. Until now it was only the understanding of what are the three parties, what are the permissions, what is the meaning of those permissions with respect to those files or directories. How to type the command chmod followed by options if any, followed by octal permissions, followed by file or directory list. Coming back to this discussion. I am back in U002 TMP. I can see there is a file called as user30 underscore prog.sh. I do not want this file to be readable, writable, executable by anybody else, by anyone else. So I should mark it as, and for me there should be all permissions. Then I should say chmod is the command to change the permission mask or permissions on a file or a directory for that matter. No options, I will not type any option. I want all permissions. All is read 4, write 2, execute 1, 4 plus 2 plus 1, 7 for me. I want group member should be only able to read this. I don't want others to have read, write or execute. Then 0. On this particular file, if I say ls, see here now, what can I do as a owner? Read, write, execute. What can group members do to this file? Only read. What can others do to this file? Nothing. They can't do anything to this file now. Provided the top level directory should not have a liberal permission. In our case, the top level directory itself is having a problem that it allows read, write, execute, read, write, execute, read, write, execute for everyone. So I am assuming the top level directory is protected, then this makes sense. So I cannot now, I don't allow now others to even do anything to that file. Clear? If I want the permissions to be very liberal, which I won't recommend you do this, then you can say 777. That means anybody can do anything to your file now. The same thing, in this case here it was a file, I could set it for a directory as well. So see here why I am doing it for a directory. I want to change the permissions to 700 on this directory. See what are the permissions now. Clear? 700. So nothing for group members, nothing for others. 700 is the most restrictive permission. Most restrictive. It does not allow anybody to do anything with your file. Typically, this is the permission set on everyone's home directory. See what I am doing now. I am going to /home where all user home directories are kept. See how all home directories are protected. So who can go in your home directory? Only you. Who can see the contents of the your home directory? Only you. Who can write, delete from your home directory? Only you. Others cannot list, other cannot see the file attributes, other cannot jump into that directory, other cannot create a file, other cannot see the existing files from that directory. Do not change the permission of your home directory to more liberal permissions. If you set it to more liberal, there's a risk. So somebody said, no, I am a global friend of everyone. I want everyone, everyone is my friend. So I said, my permissions by default are this one. So I said 777 gone. Now if I see, anyone can come into your directory and can delete your own files. They can write a virus, they can ask you to auto execute it. Never set the globally writable locations until you seriously mean. Most of the audit compliances in Unix, if they find 777, they will report it as a compliance issue. So there are audits happening periodically. The moment they detect that some directory is having 777, you are making a hacker job easy. You may be a very good person whom you don't want to play a foul play with. You said everyone should get a fair treatment. What's there to hide in my directory? It's good thought wise, not Unix wise. Clear? So don't do this. I'm changing it back. Next thing is, who can apply the chmod command? Only the owner of the file or directory and the super user obviously can change the permissions. Otherwise what would have happened? You created something very secret. You never are allowing to others to see it. And I am another user and I am changing it to 777 so that I can go and see into it what you have hidden. Isn't it? So only owner and root can do this. People say how to protect things from root. Be the root. You can't hide anything from root. If you want to hide anything from root, be a Unix sysadmin. Now nobody can see what you do, but you can see what others do. So be the root. Permissions can be changed either by using two separate styles, either or. One is absolute permission assignment. Permissions are assigned absolutely in an absolute manner. What does this mean? This simply means I don't care about existing permissions. I want new permissions to be set. This way of thinking and then ultimately executing the command is called as an absolute assignment. See it here. I don't care what are the existing permissions for this file. My targeted permissions are 755. So see how I assign. I don't care what are the existing permissions. Targeted permissions are 755 on this one. See what the file looks like now. Clear? So understand what is the meaning of absolute permissions. When you do not consider the current permissions and grant a new permission mask, it's called as an absolute assignment. The way you are working is called as an absolute assignment. So I don't care what are the existing permission, I directly want to assign new permissions. First of all, you must be the owner or you must be the root. That is always the limitation. Absolute assignment further could be either in a octal format or could be in a text format. Permission itself are assigned absolutely, but it can either be selected further as a style as octal assignment or as a text assignment. See here. What type of an assignment style I have used? Absolute assignment. And in absolute, whether it was text or whether it was octal, because I am using numbers. Now see, if I want to change it to 754, I would have said 754 this way. I got it, isn't it? I want to make it 777. I said 777 on this file. See it, done. I am using numbers to manipulate the permissions. I am not taking into account what are the current permissions. I am unilaterally driven only by my target. My target says the file should have 777 or 754. Accordingly, I am assigning the octal permission. See, what if I wanted to do using text notations? I want to set 754 so that it should look something like this. Currently there are 777. See how I am doing it now. chmod. What should owner have? 7. Owner is indicated as O. Equal to 7 means what? Read, write and execute. RWX. So I am saying owner should have RWX. What should group have? Group is indicated as a G. What should group have? Group should have 5. 5 means read and execute. What should others have? 4. 4 is only read. Others is indicated, owner is indicated as U, by the way. U is for the user or the owner. Owner should have RWX. Group member should have read and execute. Others should have only read on the file user program.sh. See here. Now this way of assigning a permission is called as textual assignment, whereas my previous one was octal assignment. So this is 754 and this is equivalent of 754. Clear? Now why it is called as absolute is another point. I told you, you do not take into account what are the current permissions. You are simply saying you want this as the permission. That's why whenever in your permission assignment you use equal to symbol, that is called as absolute assignment. There is no equal to symbol here, but I am direct. Am I considering current permissions? No. I am simply saying 777. This is as good as setting equal to 7 for the owner, 7 for the group member, 7 for others. So this is as good as saying O equal to U equal to RWX, comma G equal to RWX, comma O equal to RWX, isn't it? So user, group and others all should have this permission. Which symbol you have used? Equal to. That's why it's called as an absolute assignment. Now let's understand what is relative assignment. Before I do this, let me change the permission to 700. Clear? Only readable, writable and executable by the owner. I am simply saying on top of this chmod, I want this file to be readable and executable by group, readable and executable by others. Group is indicated as G. Group को अभी क्या permissions है? Which permissions are there? Nothing. So I said on top of current permissions, I want to add to group read and execute. For others, on top of the current permissions, I want to add read and execute on this. If I check this now, see here. So did I use equal to sign? No. So I said what that plus means? Whatever are the current permissions plus new permissions. This is relative now. This type of an assignment is relative to my current permissions. I am assigning new. So this type of permission assignment is called as a relative assignment. Clear? People say, what if I want to make, again I will make this file as 7, not 7, I will make it as uh, read and write 600. People say, what if I want to assign execute to everyone? So I said chmod 7 using octal notation. What I would have said, I want the file should have read write execute, read execute, read execute. What should I say? 755. This type of an assignment is absolute or relative? This is absolute, because I am not considering the current permission. Now see, if I wanted to give it in a relative style, how I would have given. User should have execute on top of the current permissions. Group members should have read and execute on top of current permissions. Others should have read and execute on top of current permissions. I said ls. This is it. Clear? So when your permission assignment either has a plus sign to add or a minus sign to remove, this type of an assignment is called as a relative assignment. Clear? Similar way, somebody said remove execute from everyone. So I am saying chmod user minus execute, group minus execute, others minus execute on this one. कितना बड़ा टाइप करना पड़ रहा है, सभी में से एग्जीक्यूट निकालना है, राइट? देन आई कैन से chmod a minus execute. A means all. All means owner, group and others. So you could have said a minus a. लोग बोल रहे हैं फिर a ही लिखना था तो लिखना ही क्यों? तो you can say minus x. जब मैंने कोई पार्टी नहीं दिया उसका मतलब कौन है पार्टी? All. All minus execute. I said this. See here. अगर उनको एग्जीक्यूट होगा तो वो निकल जाएगा. फिर कुछ लोग पूछते हैं उसको तो एग्जीक्यूट था ही नहीं पहले से, तो अब क्या दिखेगा? एग्जीक्यूट था ही नहीं, तो यू नीड नॉट वरी, राइट? सो इफ देयर इज ए एग्जीक्यूट परमिशन इट विल टेक इट ऑफ. सबको एग्जीक्यूट परमिशन देना है. सब बोले तो कौन? ए, ऑल प्लस एक्स. ए प्लस एक्स, डिफॉल्ट पार्टी इज एनीवेज ए, सो आई एम सिंपली सेइंग प्लस एक्स ऑन यूजर 30. See here. Now understand. While considering the current permissions, you can either add plus or remove minus permissions to or from a file or directory. So you can add a permission or you can remove a permission from the current allocated one. Such an assignment is called as a relative assignment. For read and execute, the default party is all, but for write the default party is owner. जब आप पार्टी नहीं देते और सिर्फ W परमिशन देते हो प्लस करके, तो किसको अप्लाई होता है? वो सिर्फ ओनर. सी हियर वन मोर टाइम. I said chmod 400. Got it? I want read to be given with a relative assignment. और मैं पार्टी नहीं मेंशन करता हूं तो क्या होता है देखो. I said chmod a plus read, a plus r, all plus r. a को निकाल देता हूं और सिर्फ r लिखता हूं. किसको रीड मिला? What was the default party then? जब मैंने पार्टी मेंशन नहीं किया तो यहां कौन आया फिर? All. For read and execute, the default party is all. So when you don't mention the party, it means read to all, execute to all. One more time. I said chmod party is missing. I gave execute. See who got the execute permissions? All. अब यही चीज मैं I want to try it with a write permission. I said chmod party is missing plus W on this file. To whom did I give this permission? This could be the difference between the way I am typing it in a public directory probably. I go to my own home directory, I said chmod 400 on, I don't know what files are here. There is a file called as F1. Understand what's there on the F1 as of now. Only read for the owner. Nobody has any other permission. I said chmod plus read on F1. What party? I didn't mention any party. Means read to all. Let's check. Got it? I didn't mention any party, but I wanted to assign executable. Who got it? All. I didn't mention any party, but this time I mentioned W. Who got it? Owner and group. So I must change this then. For read and execute, the default party is all. For write, the default party is owner and group. तो जब आप write permission देते हो किसी पे और when you don't mention the party, by default it applies to owner and group members. U is for owner, G is for group, O is for others, A is for all. This is the default party for read and write. Rather I should mention isn't it? When you don't mention the party for write operation, permission, then it is owner and group. When you don't mention the party for read and execute, default party is all. So understand what I am doing here. chmod a plus x file1.sh. इसका मतलब क्या है? Grant on top of the current permission, grant execute. People say what if he already has execute? So double execute. So no problem. So it will anyways ignore it. What does this means? Whatever are the existing permission, take back execute from the group members on file1.sh. So understand the permissions. You will have to do too many observations while doing this. Okay. Have you got these things so far? It may be confusing about absolute and relative. You will have to practice it. Now, nobody will ask you simple questions. I am going to use 002/tmp. I am creating a file. Touch secret.txt. I said 000 on secret.txt. Who has what permissions on this file? Nobody has no permission on this file. I am user 30. I am the owner. Can I see the contents of the file now? See, cat. See what it says? Because I do not have read permission. Can I open this file in a text editor? It allows me. And then I type to write, this is the new line. Can I save the file? It says no. Can I save this file with a bang? I said ls-l secret.txt. Although I never had a write permission, I could still forcibly open it and could still save it because I am the owner. Who can change the permission of a file? Owner. So I could have always changed the permission and would have written to that file. So it always allows you as a owner to overcome the default permissions. Although in the cat command outright rejects that you do not have a permission. But I open the file again in the VI editor. I don't see the contents. I don't see the contents. But can I forcibly write into this file? I said this thing. It says you cannot write. I said forcibly. It's written. I said ls-l. Clear? Well, it is giving me a problem. So I said 400. Can I see the contents now? Clear? So if you are the owner, even if you do not have write permission, you can always edit the file. Clear? The only thing is if you do not have the read permission, you won't be able to see what is the existing text into that file. Clear? Now if I edit it, I can see the text, I can add it, I can see it, although I do not have write permission on it. So you as a owner, even when you don't have write permission, you can still edit the file. So questions will be something like, what if a file has a 000 permission? What it will allow you? If you have a conceptual clarity of read, write, execute, and if you would have practiced these different combinations of permissions, I'm quite sure you would be able to answer it. Nobody will ask you simply, tell me what is the meaning of 755. That everyone knows. They will ask you a tricky question like, what if it is 000? Clear? Write allows me to delete a file. What is the meaning of write? Modify the contents and delete the file. Now see here. Do I have a write permission as a owner on this file? No. What if I try to delete it? It says, oh, looks like this file is write protected. Are you sure you want to delete it? I said yes. I checked, then there is no more secret.txt. So when there was no write permission, it shouldn't have allowed me to delete it. But who is the owner? I am the owner. So I can pretty much delete it also. The difference is, it only shows you a warning. Now see another case. I said touch secret.txt one more time. I have read write. I am saying chmod 600 so that others cannot do anything. Now if I delete this file, it does not show me a warning. Why? Because I anyways had a write permission and write allows me to delete. Previous case there was no write permission, so it shows me a warning that this is a write protected file. Are you sure you want to delete it? Now why it prompted me in the first place? Because I was the owner of that file. Clear? So understand the file permissions, read, write and execute on a file, on a directory. So this will, and you need enough practice to try out the various combinations. And also keep in mind, at times parent directory permissions might hamper your observation. Clear? Because parent directory itself is 777 and you said nobody has any other permission, and others like Dick can come and delete your file. So always take into account if something is not working in line with the chart that I prepared, always verify the parent directory's permissions. Clear? So very important. So that's it for this session. A very important one indeed.